Alright, we're going to talk about solving linear equations, special cases. Now, a normal linear equation is going to, look like this. 3x minus 7 is equal to 5. And you add 7 to both sides, doing the opposite operation or inverse operation, and you divide both sides by 3, x equals 4. And so what you're basically doing when you're asked to solve is you're trying to determine what is the number or numbers. There could be more than one, especially if this was a greater than or a less than situation. There could be a whole bunch of numbers. But basically you're trying to determine what value for x makes this a true statement. Okay, so 4, if I plug that back in, 3 times 4 minus 7 is going to be greater than or equal to 5, or in the original, just equal to 5. Now, you know, in the inequality case, it's true that you have a lot of answers, but if this was just straight equals, if we go back to the original where it was just straight old equals, notice that the only number that works there is 4. 3 times 4 is 12 minus 7 equals 5 is the only thing that works. Okay, so it's the only thing that makes this a true statement, and that's what solving actually means, is you're trying to find the number or find the values that make a true statement. Okay, so when I say special cases, all right, that means that there might be equations out there where it's not possible. Okay, for example, if you're solving an equation and you get to this point where maybe you have 3x minus 5 is equal to 3x plus 9, okay? And you go and try to get all your x's together on one side, and you wind up with negative 5 equaling a positive 9, and there's no x variable left. Well, that's what makes it the special case, all right? And your job is to decide, okay, well, what does this mean? Okay, well, it means you look at this. Is negative 5 equal to 9? Is it or not? No. So it's not equal. So this is a false statement, which means that no matter what number you put in for x, even if we could find one, no matter what it was, if we were to plug that in, let's just randomly pick something like 4. 3 times 4 minus 5 would give us 7. 3 times 4 plus 9 is not going to give us 7. So there is no way to make sure that this side is equal to that side. There's no way to make it a true statement. So since that's false, there is no solution for x. Okay? Actually, I'm running out of room there. No solution. Okay? So no solution to this equation because this is a false statement. On the other hand, okay, another special case is, what if we have 3x minus 5 on one side and then 3x, and we wind up with minus 5 on the other side? So when we go to subtracting our terms, our like terms, and trying to get them on the same side, lo and behold, we wind up with a true statement. Well, that means that no matter what you put in x's place, no matter what number, we're always going to get a true statement. So we could put in 4. 3 times 4 minus 5 is going to give us 7. 3 times 4 minus 5 is going to give us 7. 7 equals 7. We could pick 100. 3 times 100 is 300 minus 5 is 295. 3 times 100 minus 5 is 295. So it's always going to be true. Well, since it's always true, well, then what is your final answer then as far as what your x values will be? Well, x can be any number. All right, which means that your final answer is all real numbers. Now, in college algebra, we're going to find out that it's actually all numbers, complex and real numbers, but for right now, that's what you've been learning. Also, it doesn't matter if it's -5, -5, or if you wind up with 0 equals 0. Okay, it's still all real numbers. And up here on the false one, it doesn't matter what the numbers are, if it's 0 equals -7 or whatever, it's still false. So that's no solution. And those are your special cases. Okay.